Just like games have a core gameplay loop, working with Git projects has a core loop as well, a set of activities you're going to repeat again and again as you work through your project. The Git core loop is a little like this: create your stuff, stage your stuff, commit your stuff to history. The commit part doesn't make a whole lot of sense yet because that's a Git term of art, but making stuff and staging stuff maybe makes a little bit of sense. I spent a lot of time thinking about this, and the best metaphor I can come up with for the Git core loop is NASA space travel. Bear with me for a second. In Cape Canaveral, Florida, there is a gigantic building called the VAB, or the Vehicle Assembly Building. This is where giant rockets like the Space Launch System that's going to send the Artemis mission around the moon get constructed. It's also where the space shuttle was assembled and the Saturn V rockets that sent Apollo astronauts to the moon. It's a big building where stuff gets put together. I think you can see where this metaphor is going. The VAB is just like making stuff. We put our stuff together, whether it is code, whether it is text, whatever it happens to be. But the rockets don't launch from the VAB. They have to be rolled out to the launch pad. That is done with this massive machine called the crawler, or the mobile launch platform, where the assembled rocket is staged for launch. And then finally, of course, the candle is lit and the spacecraft lifts off for orbit. And the spacecraft lands. We repeat the same process again and again. So when we are working with Git, we can make our changes freely. There's no extra steps to it. But then we're going to run a command known as git add to stage any of the changes that we want to include in a commit being an entry into the history of our project. And that is how Git tracks changes. Adding material to staging doesn't make the commit happen. We add all of the things that we want on the launchpad, and then we use git commit to actually etch those changes into history. It's much easier understood in practice, so let's practice. I'm going to start by echoing some text into a new file. We're going to do a lot of echoing here. We're not going to spend a whole lot of time in text editors. So we're going to create a new file this way by redirecting the output from our standard output to the file1.txt. It doesn't seem like anything's changed. We have those three dots in this indicator, but if we run git status, which really is our first git command and also the most important, it tells us a couple of things. First, it says we're on branch main, which we knew because that's what we named it. We also have untracked files. These are files that are in the folder, but that Git doesn't know about yet. We haven't told Git to care about these files yet. And the output even suggests what we do next, which is git add for anything that we want to care about. That's exactly what we're going to do. We're going to run git add file1.txt. My indicators turned gold to tell me that I have staged changes. Let's run git status again. Things have changed. We have on branch main, same, no commits yet. But now we have changes to be committed. Then we can unstage them, but we don't really want to do that. We have something that's on the launchpad ready to go. Now we're ready to commit. Let's run git commit. This is going to get a little weird, but bear with me. Vim pops up because it's waiting for us to add a commit message. And because we didn't provide one on the command line, it opens the default editor for us to do exactly that. Let's add a note here. I'll press I to get into insert mode, and we'll say add file1.txt, escape, and then :X to save and quit. The commit has been made. We've created a file with this file mode. And now if we run git status, nothing to commit, working tree is clean. That means that everything that has been changed that Git knows about is in git commits already. We've made a little bit of Git history. Let's run git log to see it. There's a lot going on in git log. Let's break down the parts here. The first thing that you see is a unique commit hash of the contents of the commit, as it turns out. and a reference that indicates the branch and head, which refers to the most recent commit in our quote unquote working tree. So we're at the most recent event. Some author information, that's why we had to do that configuration before, a timestamp for the commit, and the commit message. That's what's in a long form log entry. One commit is good, two commits are better, so let's make a new one. This time I'm going to echo again. This time the contents are my second commit, and we're using two angle brackets here to append to file1.txt rather than overwrite our previous changes. Notice that my git indicator is turned red now. That means I have changes to tracked files. Take a look at git status to confirm that. Notice that now it says modified. Now, of course, we need to git add, but before we do that, I want to show you how git tracks modifications with git diff. Now, git diff can be used by itself, and it'll show you changes across an entire repo, or you can specify a file, which we'll do in this case. If you run this, you will see that there is an additional entry here. And in green with a plus, it shows the additional line added to file1.txt. Looks good. We'll run git add for file1.txt and then git commit again. But this time we can pass the message on the command line with the -m option. So we don't have to open up Vim to make that happen. You want your commit message to be descriptive, but not too long. Notice the output here says we have one file changed with one insertion. We can see both of these with git log. You can already tell this is going to get real long real quickly. So one very useful option is git log --one line, which will abbreviate the entries for you. You only need usually the first bit of the hash anyway, so that's what it shows you, and the commit message, and if there is a head, then that on the same line. Okay, that does it for the git core loop. In the next lesson, we're going to talk a little bit about commit best practices.